Do you know how flexible circuit boards are made? Flexible circuits were originally developed from aerospace technology. Because of their advantages such as thinness and flexibility, they are indispensable manufacturing components in all precision devices. The core of a flexible circuit board is an ultra-thin polymer film that's even thinner than a strand of hair. This is because it can be both folded and withstand heat. First, the machine cuts the film into the specified size according to the shape requirements of the finished product. Supported by a hard paper sheet underneath, the film is fed into the machine, where it is sandwiched between two copper foils, and then a cutter slices it into rectangles. The conveyor belt for feeding the sheets is equipped with air holes. As the belt transports the sheets, it blows air onto them, preventing the sheets from sticking together when stacked. Every 3 sheets that have been cut are then laminated together using a press board. The middle sheets are coated with a heat-activated adhesive, while the surfaces of the copper sheets on both sides are rougher and have adhesive properties. After the layers are bonded together in a vacuum chamber, the laminated board is placed into a high-temperature, high-pressure chamber. The high temperature and pressure activate the adhesive, bonding the 3 layers of sheets together. To test the adhesion strength of the 3-layer sheets, the finished bonded sample is subjected to combustion. After burning, a machine is used to peel off the top copper layer, and the force required to peel it is analyzed to determine the degree of adhesion. Once testing is complete, the sheets can be processed into circuit boards. First, a computer-controlled pressing machine cuts the sheet material into circuit boards of fixed size. At the same time, small holes are drilled so that after the electronic components are assembled and pressed, the circuit board can pass through the laminating machine. The laminating machine then sprays a photosensitive agent onto the surface of the circuit board. After spraying, the entire board is placed into an exposure machine, where the circuit board is scanned by a laser. The areas of the board exposed to the laser cause the photosensitive agent to react and harden, while the areas not exposed remain unchanged. Those unexposed areas remain soft. Next, an acid washing machine is used to clean the soft regions, removing the excess photosensitive agent and copper. The copper that remains on the polymer film after cleaning forms the integrated circuits on the flexible circuit board. Afterwards, each copper-containing circuit is inspected using computers and testing equipment. Next, a sticky roller is used to remove any dust from the surface. At this stage, the circuit board must be completely free of dust before the insulating film can be applied. After the film is applied, workers carefully inspect all the holes on the board using a magnifying glass, making sure every hole is perfectly aligned before proceeding. Then a soldering iron is used to activate the heat adhesive material inside the board. By bonding at key points, the insulating board is fixed onto the circuit board, and then a laminator is used to fully combine the two. Unlike the previous process of bonding polymer and copper foil, this time a layer of plastic film is added on top of the insulating board. This is to protect the surface of the circuit board from damage. After an hour and a half of high temperature and high pressure, all the materials are fused into a single unit. Finally, a stamping machine and mold are used to press out the excess material, and the flexible circuit board is complete. Have you learned how it's made? If you want to know how other items are manufactured, feel free to leave a comment below. You can also long press to like the video and help speed up future production.